Let's find the general solution to this differential equation. So you could solve this using the integration or integrating factor method, but this time I'm going to be using the definition that my general solution y is equal to the homogeneous solution plus the particular solution. So let's do this in steps. Before everything, I'm going to write this in standard form. So to do that, I'm going to be isolating y prime. So I'm going to be dividing by cosine x on both sides. So now my differential equation looks like y prime plus tan x, because sine over cosine is tan, equals to 1 over cosine, or just secant x. Now that I have my differential equation in standard form, I could start by finding my homogeneous solution. So to find my homogeneous solution, all I'm going to do is rewrite my left-hand side, but this time is just equal to 0 to make it homogeneous. Now to find y, I can just do separation of variables. So this is going to be y prime is equal to negative tan x. Y, isolating x and y, I have 1 over y dy is equal to negative tan x dx. Now integrating both sides, I get ln y on my left-hand side, and I don't need to add an arbitrary constant c on the left-hand side, but on my right-hand side, after integrating, you can solve the integral of tan x using the u substitution method. I don't feel like doing all the steps, and I know what it is, so it's ln cosine x plus c. And now to isolate y, I'm going to do e to the power of both sides, so that I'm left with y on my left-hand side. My right-hand side, that c gets absorbed times cosine x, because when you do e to the power of a log function of x, it kind of, just exponent and log rules. Anyways, this is my homogeneous solution. So it looks like I'm skipping a lot of steps, but you just need to know your log and exponential rules, and everything else will make sense. So now I can move on to the next step, which is the particular solution. So my particular solution is going to have the same form as my homogeneous solution, almost. However, instead of my constant c, it's going to be rewritten as a function of x. So c is a function of x this time, times cosine x. And now what I'm going to do is I'm going to find yp and yp prime so that I could plug it into my differential equation. So if this is yp, my yp prime is going to be equal to, that does not look like a p. What? Yp prime. And differentiating c of x times cosine x. Because c of x is now a function of x, I'm going to have to apply the product rule to this. So keeping c of x the same on this side, multiplying by the derivative of cosine x, so my negative sine x, plus differentiating c of x, so c prime of x, times just cosine x. Now plugging everything into my differential equation, let me scroll up to remind myself what it is. It's y prime plus tan x y is equal to secant x. So my yp, I'm just going to copy it. So this is my yp prime plus tan x times my y sub p, my particular solution. So times c of x cosine x, all equal to secant x. And now with some simplification, I'm going to rewrite this as negative c of x sine x plus c prime of x cosine x. Tan x is equal to sine x over cosine x, so the cosines cancel, so I'm left with c of x, that is one weird looking x, sine x is equal to secant x. So now I could see that my negative c of x sine x cancels with my c plus c of x sine x. So my left-hand side is just c prime of x cosine x is equal to secant x. And now I'm gonna need to find my c of x by, again, isolating c of prime. So c prime of x is gonna be equal to dividing cosine x on both sides. So secant x divided by cosine x is just going to be secant squared x. And the very last step is to just integrate both sides. And then this is going to be dx dx. C prime of x integrated just using the fundamental theorem of calculus is just c of x. Integrating secant squared x is just tan x. You could just know that. It doesn't really require much, but you can integrate it. So now that I found c of x, I know what my particular solution is. So tan x times cosine x is my particular solution, or simplified is just sine x. Now that I found both my homogeneous solution and my particular solution, I could just add them together to find my general solution. So my general solution y is equal to my homogeneous solution, which was c times cosine x, plus my particular solution, sine x, and that's it.